like scientists, mathematicians like to classify. Within the real numbers, we like to classify different types of numbers together. We call these the subsets of the real numbers. What you need to remember, though, is that at this point, anything that we've used in mathematics is a real number. That should bring up the conversation, hey, are there non-real numbers? And yes, there are. We call them the complex numbers. And we'll talk about those in just a few lessons. The subsets we're going to begin with are rational numbers and irrational numbers. Rational numbers are any types of numbers that can be written as a fraction. Examples would be 1, -1, 2/5, 2.5, since we can write that as 5/2, but also any number that repeats, 0.22222, which is 2/9. Irrational numbers cannot be written as a fraction. This would include numbers like pi, the number e, which we'll talk about at a later date as well, and any non-repeating decimals. Within the rational subset, we do have more precise classifications. We have the integers, and the integers are simply taking the decimals and the fractions out of the rational numbers. So we start, say, with -3, -2, -1, 0, 1, 2, 3, and we can go on in both directions as far as you want, as long as we don't have any fractions or decimals. Within the integers, we can break that subset down a little bit by taking the negatives out, and we call these the whole numbers. So we start with 0 and we count up, noticing we don't have any decimals or fractions as well. And finally, within the whole numbers, we can take out 0, and we have the natural numbers. We call these the natural numbers because they can occur in nature. We start with 1, 2, 3, 4. It's kind of natural that we start counting at 1. When you first started counting, you started with 1. You didn't start at 0 because you can't count 0 things. An easy way of remembering the whole numbers, if we have an O in whole, we have a 0 within our numbers. So with this, we can go ahead and look at a couple of examples of numbers. And we're simply going to ask you, hey, if I give you a number 3, to what subsets does 3 belong? Well, 3, we can count 3 in nature, so it's a natural number. Well, if it's a natural number, it's got to be a whole number as well. And if it's a whole number, it's an integer. And if it's an integer, it's rational. And if it's rational, it must be real. So what I like to do is to get the most precise subset that it belongs to, and then write everything else that goes above it. So if we look at example 2, and I give you -7. Well, -7 does not occur in nature, so it's not natural. It doesn't include 0, so it's not a whole number. So we start with the integer. So it is an integer, it is rational, and it is real. Well, example 3, what happens if I gave you the number 2.3 and the 2 and the 3 repeat? Well, now we have decimals, it repeats. So it is rational and it is real. And finally, example 4, what if I gave you the number 0.358972 and it repeats forever? Well, in this case, since it repeats, or it doesn't repeat, and it goes on forever, it is irrational, but again, it is also real. And this is an overview of our subsets of the real numbers.